In this video, I counted 274,877,906,943, otherwise known as 2 to the 38 minus 1, or 3 in the hex. For years, large numbers have been out of reach for humankind, but today, that changes.
Let's get started.
1, 2, 3, I'm joking! I won't be doing this alone. I'll be enlisting the help of my computer to count fast. I wrote this small Python script to test how fast my computer can count. As a speed baseline, it will count to 2 to the 24 minus 1, which is approximately 16.7 million. It looks like it took roughly 1.3 seconds, which is definitely faster than I can count, but I think it may be too slow. We can estimate how long it will take to reach our desired amount with this handy formula, where b is the number of bits required for our test value, and t is the time it took to count to that value. So if we convert this to hours, we get 6.2 hours. I don't have that type of time, so let's see if C is any faster because compiled languages are the best. 0.02 seconds for 16.7 million is a huge speed up from Python. Let's do some quick maths with our new time, and it looks like we get just over 6 minutes. So we're definitely approaching the limit, but let's see if we can do any better if we go to the source, x86 assembly. This might look complex, but it's actually very simple. There are a few initialization lines, but after that there are 5 main steps. First, we call the clock function to get the current time and store it in R14. Second, we increment the counter, which is R12 in the code. Third, we compare the counter to the desired amount and see if R12 equals R13. 4, if they're not equal, jump back to 2, which is represented by the count label in the code. 5, we call the clock function to get the elapsed time. And that's it. It counts to 16.7 million in under 100th of a second, which is way too fast to be confident in extrapolating the data. So let's go back and increase our base to the maximum unsigned integer, which is 2 to the 32 minus 1, which is roughly 4.2 billion. So we can just add 2 hexadecimal f's and then run the code again. It looks like it's now able to count to 4.2 billion in under a second. The formula now shows it will take about a minute, which is definitely more reasonable than before. So let's do it. Nice, our estimation was really accurate. We successfully counted to 274,877,906,943. The assembly code could count up to 2 to the 64 minus 1, but it would take over 130 years. Comment down below how fast you can count. If you enjoyed this counting adventure, like and subscribe, and I'll see you in the next one.